Hi everyone. In today's video, we will learn about AWS Auto Scaling, why we use it, what is the use of auto scaling, and what are the key features, what are the different types of auto scaling, load balancer, etc. Let's move to agenda. What is auto scaling, why auto scaling, key components and benefits of auto scaling, architecture of auto scaling, AWS load balancer, and target group. So let's know one by one what is auto scaling. Auto scaling is a cloud computing feature that automatically allocates resources to match the demand of an application or system. It's used to ensure that application have the resources they need to perform consistently and meet performance goals. Auto scaling can help reduces cost by minimizing the use of cloud resource. And in AWS, auto scaling is a core feature of elastic load balancing and work well with other services like EC2 and RDS. So the name shows that auto scaling is a cloud computing feature. It automatically allocates the resources, and also it perform consistently and meet the performance goals. Then let's go to why AWS auto scaling. Auto scaling is critical for modern applications, especially in cloud environments where workload demands can vary significantly. Some auto scaling essentials optimize the cost, maintenance performance, speed up development cycles, scale multiple resources, set target utilization level, automate scaling. So let's know one by one. Optimization cost. You only pay for the resources you need and you can avoid over provisioning and underutilization. Means it only pay for what you use and what resources you need. The maintain performance. AWS auto scaling monitors your applications and automatically increases the capacity which demand spikes. The next is speed of development cycles. Can automatically change the resources for CI/CD pipelines to ensure the builds and deployments are completed promptly. The multiple resources. Auto scaling to scale multiple resources across multiple services. It includes the EC2 instance, ECS tasks, and Amazon DynamoDB tables. Set target utilization levels. You can define target utilization level for each group of resources. The next is automating scaling. You can automate how groups of resources respond to changes in demand. The AWS auto scaling use the AWS management console and command line interface or SDK. So this is all about why we need auto scaling. The next is key components of auto scaling. The main key components of auto scaling are launch configuration, auto scaling groups, scaling policies, scaling cooldown, health checks, CloudWatch alarms. So let's learn one by one. Launch configuration. This is the set of guidelines for the instances that auto scaling will launch. It includes details like AMI, Amazon Machine Image, and instance type, key pair, security groups, and block devices mapping. The auto scaling groups. There are instances that auto scaling manages together that specify the minimum, maximum, and desired number of instances, along with the scaling policies that detect how to adjust the number of instances. The next is scaling policies. These rules determine when and how auto scaling should add or remove instances in auto scaling groups based on certain matrices like CPU usage, network traffic, or custom matrices from CloudWatch. The next is scaling cooldowns. Cooldown period help prevent sudden changes in the number of instances by imposing a waiting period between scaling action. This stabilizes the system and minimizes unnecessary adjustment. Health checks. Auto scaling conduct health check on instances to make sure they are operating correctly. If an instances fail a health check, it's terminated and replaced with a functioning one. In the demo session, I will show you how it's all or work. The next is cloud check alarms. The Alarm monitor system matrices and trigger the scaling actions when certain thresholds are met. You can set alarm for various performance matrices to ensure the response systems. The next one is life cycle hooks. This allows you to perform specific tasks before instances are launched or terminated during the scaling process. For instance, you can prepare instances before they go live or clean up before the shutdown. So this is the key components of auto scaling. The next is benefits of auto scaling. By adjusting resources according to demand, auto scaling helps prevent over provisioning and cut down on wasteful expenses during the times of low traffic, and it guarantees the application maintain optimal performance and automatically boosting the resources, and it adding or replacing the instance that fail. Auto scaling helps application availability and guarantee users have constant access to services, and without the need for manual intervention, it enables business to swiftly adjust to shifting workloads and successfully handles or increase or decrease in demand. It mainly helps to prevent the over provisioning, and it cuts the wasteful expenses, and it maintains the performance and automatically boosting the resources, and it easily adding and replacing the instances is fail, and it doesn't need any manual intervention. It enables business workloads and successfully handle the increases or decreases based on the demands. These are all the benefits of auto scaling. The next is architecture of auto scaling. Here we see there is a internet gateway, VPC, the load balancer, the auto scaling group. It's launched the templates. There is a subnet to create the EC2. So this is the number of instances we can create. The minimum is 1, the maximum is 3, the desired functions are 2. So this is the target group. I've already explained. I will explain this one by one. So in this VPC, when auto scaling group launches the instances, they are placed in the specific subnets and VPC. And the auto scaling group, here we can see auto scaling group will create the new instance in the specified subnets. Within the VPC, it can automatically scale the number of instances up and down based on matrices like CPU utilization, memory, or custom applications. And the target group the load balancer integrations, elastic load balancer in AWS, similar services in other clouds distribute the income traffic to healthy instances. So in case it's unhealthy, it terminates and create the healthy instances. And the auto scaling group contain minimum, maximum, and desired capacities. The minimum is the minimum number of instances that must be running it at all times. The maximum is upper limit of the number of instances the group can scale, and the desired capacity is the ideal number of instances the group should have. So these are contained the auto scaling group. The next is scaling policies. In the scaling policies, it contains the target tracking policies and step scaling policies and simple scaling policies. It automatically adjusts the number of instances to maintain the target values. The next is the launch configuration and launch template. These are all launch the configuration. The instance should be configured when they are created. It includes the AMI, instance type, security groups, and key pairs, and the user data. So how the components work together means in the VPC and subnets, they are placed in the specific subnets, and in the auto scaling groups, it automatically select the number of instances, and in the target group and load balancer, the application load balancer or network load balancer is used to distribute the incoming traffic among the instances in the auto scaling group, and the VPC security settings controls the inbound and outbound traffic, and security group can be applied to both the instances and the load balancer. So this is about the architecture of auto scaling. So it all helps to create the instances. The next is, what is load balancer? Load balancing is a technique that distributes the network traffic across multiple servers to ensure that no single server is overwhelmed. The load balancing is essential for modern application which must process millions of users simultaneously, and load balancing improves the application responsive, increases availability and reduce the latencies. So the mainly it helps to work across multiple servers without any no signal server is overwhelmed, and it's essential for the modern applications also. It increases the availability. How it works: a load balancer sits between the user and server group, identifying which server is best able to meet a client request. It then distributes the request to the server. So it works based on the client information and which is able to meet the client request. So which one is easily fulfilled. So based on that, it distributes the request to the server. The next is key characteristics of load balancer. The main key characteristics are traffic distribution, high availability, scalability, optimization, health monitoring, SSL termination. So let's see one by one. Traffic distribution. To keep any one server from becoming overburdened, load balancer divide the incoming requests evenly among several services. So in the traffic is it divides the services into different. High availability. Application reliability and availability are improved by load balancer, which divided the traffic among several servers. The load balancer reroutes traffic to servers that are in good condition in the event that one fails. The next is scalability. By making it simple to add the servers or resources to meet growing traffic demands, load balancer enables the horizontal scaling. The next is optimization. Load balancer optimizes resource utilization, ensuring the efficient use of server capacity and preventing the bottlenecks. Health monitoring. Load balancer often monitors the health of servers, directing traffic away from servers experiencing issues or downtime. SSL termination. Some load balancer can handle SSL, TLC encryption and decryption. So it helps to intensive tasks from the servers. The next is, what is target group? A target group in AWS resources tells a load balancer where to send traffic and can route traffic to variety of targets, it including EC2 instances, fixed IP addresses, AWS Lambda functions and containers. The target group allow users to route the traffic, monitor the health, create multiple target groups, use weighted target groups. So what are all do in the target group means, so target groups can create route traffic to variety targets, and it allows to route traffic means it defines the rules of routing request based on the attributes like client's origin or the request path. So in the route traffic based on the client request, it can be define the rules. The monitor health. Check the health of registered target and take action if needed. So it's checking, and if you need any action, it take it. And create multiple target groups. Create different target groups for different types of the requests. Use weighted target groups. So distributed traffic to multiple version of an application by specifying a weight for each target group. So when creating load balancer, it uses the configuration listener rules to direct traffic to a target group, the target group, and route request to the healthy targets only. So this is all about the target group. The next is real world scenario. In AWS Auto Scaling, where we are using in the real world scenario. So auto scaling is widely used across various industries and scenario to efficiently manage the cloud infrastructure and dynamically adjust the resource based on the changing workload demands. Now, here are some real world use scenarios cases for auto scaling. So first one is web application, e-commerce websites, and media streaming platforms. In the web applications that encounter varying traffic pattern throughout the day for or frequently subjected to auto scaling, and it automatically adding or removing the instances based on the traffic value. In e-commerce website, it frequently increases during the sales, promotions, and holidays, and these websites can automatically scale the resources to meet rising demand. The next is media streaming platforms. So, demand for media streaming services, it fluctuates based on the time of day and the popularity of the material. This instance can instantly scale their streaming infrastructure up or down. So auto scaling generates guarantees the user streaming and playback. So this is about the real world scenario where we are using the auto scaling in different industries and cloud infrastructure. So let's go to the AWS account and create the VPC. So let's see how it creates the instances. So yeah, VPC. We need to create the VPC. So here we need to select VPC and more for the networking resources, and here we give the name of the VPC. So here I am giving as scaling, and it takes the CIDR block, and these are all defaults, and number of availability zones are 3, and number of public subnets 3, and here number of private subnets I am giving as 0. And remaining or seeing the CIDR block is 10.0.0.16. then that's all. Here we giving us create VPC. So VPC is created. So here VPC created, subnets created, and internet gateway is also created, and attach the internet gateway, and route tables also created. Here we can go and view the VPC. So here we can see VPC is created, it's available. Then go to subnets, refresh this. Here we can see subnets is created, and go to route tables. Route table is created, go to internet gateway. So internet gateway is attached to the VPC. So and go, the next is go to the internet gateway. So go to route tables here. Here you can see route tables are attached. Go to subnet association. So subnet association also attached to the VPC. Then the next resource we are creating is target group. The go to EC2 instance. So in the EC2 we are creating the target group to auto scaling the instance. In this load balancing there is a option target group. So here create target group. So choose the target group type as instance only and give the name of target group. Here I am giving EC2 target. Then here you need to select the VPC which one you are creating. So I am creating the scaling VPC and the protocol as HTTP only. The next is give the option next. The next is there is a registered target. So here no instances is created yet. Those instances are created by using the auto scaling only. Here we need to create empty target group only. So let's create the target group. So here we can see it successfully created the target group. The name I have mentioned is EC2 target. So after this, go to load balancer. In this load balancer, we need to create the load balancer. Here, select the application load balancer. So when you need the flexible feature set of your application, so we need to select the application load balancer. So create. Here, give the name. So I'm giving as EC2 load balancer. Then here we need to select the VPC which one I've created. Then need to select the availability zones. So select all availability zones. The next is security group. Here we need to create the security group. So click on create a new security group. So give the name of security group. So here I am giving as EC2 security and description is allows as such, and then here select the VPC. Then there is a inbound roles. Here we need to add the inbound roles. So here select the HTTP. So select IPv4. The next is create the security group. So in inbound roles we need to add only HTTP and the source as anywhere IPv4 and create the security group. Here security group is created. Then go to load balancer, refresh this, select the you created security group, and then go to listener and routing. Here you select the target group you created, and then so remaining are all same. Then go to summary. There is a configuration and security group you are selected, and the network mapping, the reason you are selected, and the routing tables. Then you need to create the load balancer. The new icons are not allowed, so cancel this. EC2. Then creates load balancer. Yeah. So here load balancer is created successfully. The next thing what we need to do is we need to create a auto scaling group. So here select the auto scaling group. Here we need to create an auto scaling group. So give the name of auto scaling. Here I'm giving as EC2 auto scaling. Then here we need to create a launch template. So click on create launch template. So here give the name of launch template. EC2 instance template, and give the description as web server only. And here we need to select the quick stats. So here I'm selecting Ubuntu because Ubuntu is familiar to me. The next is so here we need to select the instance type. So I'm selecting t2.micro, it's a free tile eligible. The next we need to create key pair. So here I'm selected a key pair as Ansible, and then click on the create security group. Give the security group name as template security, and give the description hello SSH, and then select the VPC, add inbound security rules, and we need to add SSH, and then source type as anywhere. The rest will be same. The rest will be same. Then click on create launch template. It's created successfully. Then go here, refresh this, select the launch template, then click on next. The next here, select the VPC you have created and select the availability zones, and the next is click on the next. Then here there is integrate with other service, there is load balancing. Here we need to select the attach an existing load balancer, and then select attach existing load balancer, and then here we need to select the target group. And the next is after selecting target group, we need to enable zone shift not necessary, then turn on the elastic load balancing. We are setting the time as 20 seconds. Click on next. Here we need to give desired capacity as 2 and minimum desired capacity is 1 and maximum as 3. The rest will remain same. Yeah, the rest will remain same. Click on next. So click on the next. Oh, there is no text. Click on next. So yeah. So click on create auto scaling group. Yeah, auto scaling group is created. Then go to EC2 instance. So here go to instance. Yeah. Yes, this instance has been created and the T2 micro instance type. So in the reason the instance has been created successfully using the auto scaling group, then go to auto scaling group, go inside this. Here there is the details of the template and automation scaling, the instance management. Here we can see the two instances are created. They are the LT status or they are in LT status. So the next is in EC2 go to EC2, terminate the one instance. So when we terminate one instance, the another instance has been created. So let's instance type, terminate the instance. So here we can see one instance has been terminated, the other instance start the running. So go to auto scaling group and refresh this. So here also we can see the one is terminating, that's the status in unhealthy status. The other one is created, that's healthy status, the life cycle is in service. So this is how we can create the instance using the auto scaling, and how to terminate one instance and create the another instance with the help of auto